This question touches on the acceleration of the air molecules along a sound wave. To solve this question, we have to understand that the acceleration of the air molecules is related to the oscillation of the air molecules. So let's consider an air molecule that's oscillating left and right about its equilibrium position, which we call x equals to 0. So if you recall in your topic of oscillations, when the particle is displaced to the left of the equilibrium position, the displacement is towards the left, while the acceleration is directed towards the equilibrium position and thus towards the right. Similarly, for the particle that is displaced to the right, the displacement is towards the right, while the acceleration is pointing to the left. Now let's consider information in the question. In the question itself, 4 points are identified with their respective accelerations at that particular time. So basically, we're also told that rightwards is positive. So based on the acceleration versus position graph, particle A will have an acceleration that is in the rightwards direction, while particle C will have an acceleration that's at the leftward direction, while particle B and D will have zero acceleration. Referring back to the oscillation of particle, acceleration is zero at the equilibrium position. So one thing we can deduce that is that B and D must be at the equilibrium position. Since compression and rarefactions occurs when the particle is at equilibrium position, we conclude that B or D must be the answer we want for this question. To determine whether B or D is the rarefaction, we have to consider the displacement of the particles on the left and right of B and D. Let's first consider particle B. Let's consider a particle that's just to the left of B and just to the right of B. Let's call it X and Y. So now the drawing here shows the particles at their equilibrium positions. According to the graph, point X has an acceleration that's towards the right. This is only possible if point X was displaced to the left of the equilibrium position. On the graph, point Y has a negative acceleration, which is referring to acceleration to the left, and this is possible if particle Y has been displaced to the right of its equilibrium position. Now let's do a similar comparison for particle D. Let's consider a point P just to the left of particle D and a point Q just to the right of particle D. So first, let's draw these three particles in their equilibrium position. According to the graph, particle P has a negative acceleration, that's acceleration to the left. This is possible if particle P has been displaced to the right of its equilibrium position. For particle Q has an acceleration towards the right, and this is possible if particle Q has been displaced to the left of its equilibrium position. So comparing particle B and particle D. For particle B, its neighboring particles are displaced away from it, while for particle D, its neighboring particles are displaced close to it. So based on this, it's obvious that particle B must be the rarefaction, and therefore the second option is our answer.